Okay, in this one, we've got P of X is equal to the square root of, now we've got a negative X and a minus 5. All right, so we have a negative sign and we have a subtraction. Now, we've seen that the subtraction is a shift, but this one, we have to do a little bit of work here. We have to do a little bit of manipulating here because this is not, it's not going to end up actually being a minus 5. So what we need to do is have that negative sign in front of the X. Well, if we're going to use, the fact that f of negative X, right, is a reflection of the graph horizontally, left to right, over the y-axis. Well, that negative sign has to affect everything under the square root. So what we have to do is, let's see, we have to make that negative sign affect also the 5. That's what we're going to do. Something we've done before, which is factor. So we'll factor out a common factor of -1. Okay, so if we pull out that negative sign, we're left with an X and a plus 5. If you were to distribute that negative, you would get back exactly what you started with. So we needed to do this because f of negative X, or a negative sign under the square root, will be a reflection of the graph horizontally. So let me use blue on the graph. So that'll do this. It'll take the graph and boom. Now it's going that way. That's just the graph of y equals the square root of negative X. Haven't done the plus 5 yet. Haven't done the plus 5 yet. Now, the plus 5 is a plus on the inside. That's a shift to the left. So for this problem, we're using these two transformations, a reflection over the y-axis, or a horizontal reflection, which we're going to do first. And then we have a shift of 5 units to the left. So this entire blue graph is going to go to the left. Everything's going to move to the left 5 units. Right, so let me erase those little arrows. So our final answer here is going to start, I don't know, the point I'm moving, like the way I'm drawing this, I'm going to start with the point -5, 0, -5, 0, because we started here with the point 0, 0. That point on the red graph, we started at the point 0, 0, reflecting the graph over the x-axis, or over the y-axis, sorry, and now I'm going to stick with green for our answer. Let's go green again. So now our final answer, I'm going to erase the blue one because that was sort of our work in between. But we've got the red one is the, let's see if I should write this down here. The red one is the y equals the square root of x. And the green one, that's our final answer. That's P of x equals -x minus 5 square root, right? So same shape, different direction, different location, but same general shape. You know, another thing you could do with this one, to alleviate any of the confusion, because this is a confusing one. It's not as straightforward as the previous few. What we could do is we could find the domain of this function. I mean, we're done, so we don't have to, but the domain of this function, we would do -x minus 5 is greater than or equal to 0. Greater than or equal to 0. Whatever's under the square root can't be negative. So the original function, I'm looking right here, P of x. The original function, there's a -x minus 5 under the square root. So the -x minus 5 has to be bigger than or equal to 0. Then we want to solve for x. Add 5 to both sides. All right. If this doesn't look like a review at this point, you have to go back and watch one of my previous videos where we talk about the domain of a function. That was back in section 1.1 and 1.2. We can multiply both sides by -1 to get rid of that negative in front of the x. Negative times negative is positive. And whenever we multiply or divide by a negative number, so we get x on the left, 5 times -1 is -5. And whenever we multiply or divide by a negative number, in this case, -1, we have to change the direction. Right? So what does this tell us? Well, if we find the domain, this tells us, okay, well, all of the x values on the graph, or for x values of points on the graph, have to be either equal to 5 or less than 5. And that's exactly what we have here. Here's the domain. All right, so that lines up with our graph. So you could have actually started with the domain. It's just another way of looking at this problem. Okay, so that's number 4. I think that was the trickiest one in this particular problem set. So a couple more of these transformation problems. I want to cover as many bases as we can. Okay, now we're up to q of x. We started with f and g and h. Now we're up to q of x. We've got 3 times the square root of x plus 4. 3 times the square root of x plus 4. Well, the plus 4 on the inside, that's something we've seen before. So we're definitely going to be using a shift to the left, right? A plus addition on the inside, that is a shift in the horizontal direction. As always, we're starting with the simplest version of this type of function. We get the point 0, 0. This is going on forever, and this is the graph of y equals the square root of x. Now we want 3 times the square root of x plus 4. Now we've got something new here. We've got stretching. So there's 2 types. There's with a multiplication happening inside of the function. So for example, if we had, let's say, f of x equals the square root of 3x with a plus 1, something like that. Or maybe we could do plus 4. Yeah. This would be multiplication inside of the function. This would be f of k times x, something times x, right? The multiplication is happening under the function, inside the function. But that's not what we have in this case. We have, in this case, let's get rid of this for now. In this case, we have some number, k. In this case, the k is the 3, right? We have a number multiplied by some function of x, right? In this case, the k is the 3, and the f of x is the square root function. So what does that do? Well, we go down to this table, this first table, horizontal stretch, vertical stretch. If it's inside with the x, you always do the opposite. If it's outside, you do what the operation is. What the operation is. In this case, it's multiplication. So what we have here, that's times 3, right? Or 3 times the square root of x plus 4. So what that's going to do is multiply all of the y values by 3. Multiply all of the y values by 3. All right, so these are the two transformations we're working with right now. Now let's go over to this graph. I'll put the y equals the square root of x a little bit off to the side. So we're gonna need some of this room. So this is the red graph. Y equals the square root of x. Now there's some points on the graph that we are aware of. For example, when x is 1, the y value is 1. The square root of 1 is equal to 1. I'll write that a little bit neater. That's 1, 1. When x is 4, the y value has to be 2 because the square root of 4, when x is 4, is equal to 2. The square root of 9 is 3. So this point is another point on the graph that we know is whole numbers. When x is 9, the y value is 3. Okay. So those are 3 points on the graph. If we forget about the +4 for right now, because we could figure out what the 3 does, and then we can move by 4. So let's look at what does let's say we have q of x equals 3 times the square root of x. I'm going to write it in blue. Q of x equals 3 times the square root of x. Well, every y value is getting multiplied by 3. The x values stay what they are. So the point 1, 1 becomes the point 1, 3. We multiply the y value by 3. The next point, 4, 2, the y value is 2. If we times that by 3, we get 4, 6. The next point, 9, 3, if we times the 3 by 3, we get the point 9, 9. See, we're multiplying the y value by 3. So we get this vertical stretching. Right, the graph is sort of being pulled up and away from the x-axis. We haven't done the +4 yet. So I'm doing this in kind of 2 steps. So now let's say, what would q of x equal 3 times the square root of x plus 4? What would that look like? Well, the 4 is a shift to the left, the +4. So each of these points goes 4 units to the left. 1, 2, 3, 4. 1, 2, 3, 4. This one also, 1, 2, 3, 4. All right, so I took each of those points that I labeled in blue. So it's like step 1, stretch the graph vertically, and then step 2, move that vertically stretched graph, move that blue graph every point left by 4 units. So then you get -4, 0 instead of 0, 0. Okay, and now we could just, we could label more points if we wanted to, but we're just sort of drawing an exact copy of that blue graph. Okay, I missed the points, but it was close enough. All right, so that green one is our final answer. So I'm going to go ahead and erase the blue and the arrows. We don't need that. We don't need the 9s. We don't need that point. Okay, so stretch the graph vertically and shifted it to the left. Okay, so let me get rid of that scribble. So this would be the graph of q of x is equal to 3 times the square root of x plus 4. Yeah, you could have 2 transformations in one problem. You could have 3 transformations, 4. You could have 5 transformations in one problem. There's a it can get complicated, but the good thing about these problems is you could break it down into single steps. So what I'm doing here by highlighting on this table on the bottom left of the screen, just identifying which transformations apply to the problem. Let's look at the next one. Okay, we've got t of x, or up to t now. T of x is equal to the square root of x plus 6. So x plus 6 under the square root, and then we've got a minus 3. All right, so we've got the point 0, 0. This is the graph of y equals square root of x, okay? Now we've got, so this is all of our transformations. This is it. This is everything. So what applies? What applies to this problem? Well, we've got addition inside of the function. We've got addition inside of the function. So we're going to be doing this. We're going to be moving the graph left 6 units. Then we've got a minus 3 on the outside. So subtraction outside of the square root. So outside of the function. So we're going to be doing this. The graph is going to shift down. So we're going left by 6 units. And we're going, oop, didn't want that. We're going down by 3. Left 6 and down 3. So I'm going to go straight from the y equals the square root of x to our final answer. Left 6. So we're going over here to negative 6 on the x-axis, and then down 3. So that'll be the point negative 6, comma, negative 3. Negative 6, negative 3. And now we draw the graph. Same shape as the red one. It's just starting in a different location. Okay, so with every one of these problems that I have just done, not just in this video, this is part 2, but also in those slides in the part 1 of this video, all of these problems you could have done any of the 3 methods that we've talked about so far. You could have graphed by plotting points, point by point, one by one, until you got a picture of the graph or an idea of what the picture of the graph should be. You could have typed these into a graphing calculator or into Desmos, hit graph or hit enter, and on the screen you would have seen the picture of the graph. Or you could graph using transformations. You could graph using transformations. In this last example, this is going to be the last one we do. We don't have an actual we don't have the function itself. We don't know what function this is. So there is nothing to type into the graphing calculator, nothing to type into Desmos, nothing to plug x values into. So really, the only way to do this problem is by transformations. And again, we've got them all right here, right? I've got all possible transformations, moving left, moving right, moving up, moving down, stretching horizontally, stretching vertically, reflecting horizontally, reflecting vertically. This is everything you could possibly do. So what's going on? What's going on with this function up here? Use the graph of y equals f of x. That's the blue graph. Let me highlight this in blue. Right, y equals f of x are those two blue lines. Those two blue lines. Yeah, closed circles on one end of each, open circles on one end of each. So those two lines make up the graph of y. Y equals f of x, or of f of x. Now, we want to graph g of x. And g of x is a transformation of, g of x is a transformation of f of x. Right? G of x is a transformation of f of x. So to get the g of x function, we start with the f of x function. We do something to it, right? And then we get the g of x. It'll leave a little bit more room. Well, what are we going to do? What are we going to do to the f of x function? Well, there's a subtraction, right? What I just highlighted in yellow. There's subtraction inside the f function. So there's going to be a shift to the right. So I'm going to highlight that, shift to the right. I'm seeing a subtraction on the outside. There's a -2. So subtraction on the outside means we're shifting the graph down. Then I see multiplication on the outside. So there's a 1/3 and a negative sign. So -1/3. So there's actually two, what I just highlighted here in yellow, that -1/3, that's two different transformations. That is a negative on the outside. So that's reflecting the graph vertically. Negative on the outside. And a multiplication on the outside. So there's a 1/3 on the outside. So that means we're right here. K times f of x. In this case, the k is the 1/3. So it looks like these four apply here. These four apply. Because we've got, we use some arrows here. We've got a negative sign. We've got a times 1/3 on the outside. We've got a -1 on the inside. We've got a -2 on the outside. Right, so we got four transformations. So let's think in terms of order. How should we do these things and ensure we're doing them in the correct order? So I'm thinking PEMDAS, order of operations. Please excuse my dear Aunt Sally. So parentheses comes first. Parentheses got to come first. That's the P. E is exponents. There's no exponents here. M is multiplication. So we've got these two transformations on the outside. I'm going to put step 2 and step 2. Right? They both have to be like maybe it's better to say I'll say together 2 and 3, right? It doesn't matter if you do the negative first or the 1/3 first, because that negative 1/3, that's two multiplications. It's like having a -1 times a 1/3 times the f of x minus 1 minus 2. So those the negative 1/3 out front, that's two multiplications. Order doesn't matter with multiplication. So you can do the negative sign first or the 1/3 first. But they have to come before finally the subtraction on the outside. So the S at the end of PEMDAS is subtraction. So that's going to be step 4, just following order of operations. So step 1 is the parentheses, the -1 on the inside. Everything moves to the right by 1. So I'm going to draw red here. See, every point is moving to the right. This point 0, 0 is going to move to the right. The point 0, -3, that's an open circle. That's going to move to the right. And the other one, 5, -3, that's going to move to the right. So every point shifted over to the right by 1. So if we wanted to draw the graph of f of x minus 1, we haven't done the negative sign, the 1/3, or the -2. Just the -1 on the inside, that takes the blue graph and turns it into the red graph. So we're going right by 1. Right. Next, we've got the negative sign and the 1/3. I'll just go left to right. I'll do the negative sign first and then the 1/3. Like I said, you could do the 1/3, then the negative sign, either way. So let's do the negative sign next. So let me make that red just so I'm consistent. All right, so we're doing the vertical stretch. We are doing that second. Let me do this in a different color. Let's go with, I don't know, orange. So negative f of x minus 1. So the x minus 1 made the blue graph into the red one. Now the negative sign is going to take everything and reflect it to the other side of the x-axis. So this red open circle right here on the bottom left, that's the point 1, comma, -3. So that's going to reflect up to 1, comma, +3. We get a mirror image on the other side of the x-axis. This point right here, which was 6, comma, -3, the open circle, is going to move up to the top of the x-axis, right? Just like the other piece of the graph. So instead of 6, comma, -3, it'll be 6, comma, +3. All right, so that's two transformations. Move to the right by one and then flip it up. Flip it up. Vertical reflection. So I'll say reflect over x-axis. Reflect over x. So now we're done with the red one. I'm going to erase the red one, so our graph doesn't get too cluttered. So now that's two steps down. Next, we're multiplying every y value because of the 1/3. We're multiplying every y value by 1/3. Every y value by 1/3. So let's switch colors again. So now we're incorporating the negative sign, the 1/3. But we're not touching the -2 at the end yet. So every y value gets times by 1/3. So if you look right here, that's the point 1, 3. The y value is 3. If you times that by 1/3, 3 times 1/3, you get 1. And the other point stays on the x-axis because 0 times anything is 0. And then we got the point 6, 3 times the y value by 1/3. Now we're down to 6, 1. Right, see how to get from that orange graph to the purple graph, we compressed it down because the vertical stretch was actually a fraction, 1/3. So we're basically stretching by 1/3, which means another word for that is compressing. So we did that third. And now finally, so we're done with the orange graphs. We've moved it, we've flipped it, we've compressed it down. And now finally, the -2 on the outside. We'll say compress y, compress the y values. And now the last thing, the -2, that's going to shift the graph down. Shift the graph every point down 2 units. I'm just conveniently sticking with the closed circle and open circle at the ends of this segment, at the ends of this line segment. So we'll do that last. This will be step 4. I don't think any individual step is terribly difficult, but it's putting 4 different transformations in the same problem that maybe it becomes an issue. So every point's going down by 2. So we take this first point right here, move it down 2 units. So now it's right here. And every point is going down by 2. So this open circle is going down 2. This closed circle is going down 2. This open circle down 2. And we get finally let me get rid of the purple. We're done with the purple. Again, that was just like the work on the way to getting our answer. So we're done with that. We're done with that. We're done with those arrows. All right. So that blue graph, that is the f of x. And that green one, let's label this correctly. That green one is going to be -1/3 f of x -1 -2. Whew. This was a tough one. So in this problem, to get from f of x to g of x, we did 4 things in this order. We moved the graph to the right 1 unit. Then we reflected over the x-axis. Then we compressed in the y direction. And then we moved the entire graph down 2 units. Okay, that does it for this one. I wouldn't be surprised if you had to, go back in the video, watch this part twice for number 7 here. But either way, that's it for now. I hope this was helpful.